Hello, welcome back. For this lesson, this is the third lesson in a series that's covering the topics of representing, naming, and evaluating functions. We already covered in the introduction different ways to represent a function, and we went over this exercise here where we just matched found function values and identified range. And then in the second exercise, we also looked at evaluating functions again, identifying range. And in exercise 3, we also checked if a function was true, and then talked about if we changed the domain, would the range still be okay? And the answer in that case was no. So, exercise 4 asks us to write 3 different functions, polynomial functions, such that f of 3 equals 2. So we're just going to write 3 functions that result in this being true. Okay? So, whatever we write over here, when I plug a 3 in for this x, this needs to equal 2. So we have to think about what we can do here. Okay, so a very straightforward option would to be let f of x equal 2. Then, no matter what we put in for x, 1, 2, 3, 4, 5, etc., okay, it'll always be 2. So f of 3 will give us a 2 there. So there's 1. That doesn't require too much from us. Let's come up with another one. Let's use one that has like an x in it, like this. Okay, now if I put in 3, I'm going to put a 3 in for this x, but we need it to equal 2. What can I do to 3 to make it become a 2? Think about that. Answer in your head. Pause the video and think about that. What can we do to 3 mathematically to make it become 2? Well, one way to do this is to subtract 1. So our function then will have the minus 1 up there. And this will result in a 2, and so check that works. So there's 1, there's 2, we need a third one. And there's, again, more options for us here. For example, we could, instead of putting just an x, we could put like a x squared. Okay, if I do f of 3, that will be 3 squared, which is 9. And what can I do to 9 to get 2? We can subtract 7. So we'll do x squared minus 7 there, and then that will result in 9. So there's our third function. Okay, and we have lots of options here. For example, I could have done another one here with just x. Maybe instead of just x, I put a 2x here. So in that case, f of 3 would be 2 times 3, or 6. Oops, I'll do it this way. What do I need to do to 6 to make that become a 2? Well, we just subtract 4. And so there's another function. Okay, and there's an infinite number of these functions we could come up with that would just make this true. Oops. All right, next, last exercise here. Yeah, okay. So the domain of this function, the domain and range of this function are not specified. Evaluate the function for several values of x. What subset of the real numbers would represent the domain of this function? What subset of the real numbers would represent its range? Okay, this is a pretty tricky question here because we haven't talked about square roots and things yet. So we'll do our best with this as we can, but don't fret too much if this is really hard. We're going to cover square roots in another later unit too. So anyway, let's talk about the domain first. Okay, are there any x values that I plug in here that will cause a problem with this function? And the answer is yes. Okay, one important property of square roots, especially if we're trying to deal with real numbers, because again we're talking about real numbers here, is we never want to take the square root of a negative number. Okay, and we could do that here. For example, if I put 0 in for x, it would be 0 minus 2, and so I take the square root of negative 2. Which is going to give us an imaginary number. Okay, so we're not going to do that. So then how can we know what x values are okay? For example, 4 works. 4 minus 2 would be just the square root of 2. And that's a positive number. Okay, so that's real. We're okay with that. So how do we know what to do with the domain? Well, we want this x minus 2 to be positive. So in other words, we want x minus 2 to be bigger than 0. It's also okay for it to equal 0. We can take the square root of 0. So we can solve this here. Okay, let's just solve it. So we'll add 2 to both sides. And so we see a rule here. All x values greater than or equal to 2 are going to be okay. So our domain is going to be x values greater than or equal to 2. What about the range? Well, again, for a square root, the smallest that a square root can be is 0. Okay? So the range is going to be y is greater than or equal to 0. Okay? Because anytime we take the square root of something, it's always going to be positive or 0. Right? The square root of a positive number is positive, the square root of 0 is 0, and so we get this domain and range. Okay? So in summary here, okay, given an algebraic expression, one variable, an algebraic function is a function f that takes your domain to your range. It's really strange that they're using a d and a y there, but so it goes. Okay, such that for each variable x in the domain d, f of x is the value found by substituting or plugging in the number x into all instances of the variable symbol in the algebraic expression and evaluating. Right, so you just plug the x, you plug this x value in for all the x's in your function and evaluate. Okay, this is going to be the way we define functions going forward. Good, they finally let that happen. Okay, so here we have another example of our limited domain where x is greater than or equal to 0. And here's another limited domain right here too. Okay? All right, that's it for this video. Thank you guys, and we'll catch you next time.